Hey, hi everyone. My name is Varsha and welcome to Study with Varsha. So, yes, today we are going to start Docker and I will try to cover all the critical part in this same video itself. So, this video is going to be pretty long because I will try to uh, explain all the theoretical part today and tomorrow I will explain the practical. So, it will be more than 1 hour, so take one water bottle and be sit and relax. We are going to learn Docker today. So first thing is that Docker is a containerization tool. So first we will try to understand what is Docker and then we will proceed further. Okay. So what is Docker? So Docker is an OS level virtualization. Virtualization we have discussed yesterday. What do you mean by virtualization? Creating a logical object version in place of actual object version, and that only we will call as a containerization platform. So which will allow application to share the host kernel instead of running a separate guest OS like a traditional virtualization. So this design makes Docker container lightweight, fast, portable while keeping them isolated from one another. Now, this is written in Go programming language and supported Windows macOS Linux installation. And it will solve work on my machine problem by ensuring code run identically across environment. And unlike VMware hardware level virtualization, Docker operates at the OS level. So this is about Docker. Okay, so if you will not understand, let me explain what it is. Previously, if you want to, not previously, like if you want to run in your machine and something, take an example, if it need only one CPU and 2 GB of RAM. Now, previously, what we used to do, we will use to take full system. So we are using only one CPU and 2 GB of RAM. Other are wasting. So to avoid that, whatever the size we need, that much only we can use. Now try to understand this thing. You know how? By taking an example before Docker, what the situation was. So before Docker, deploying application across environments was often difficult because dependencies, config and OS variations caused work here but not their headache. So take an example. This is virtual machine architecture. So this is host OS, and in the top of the host OS, hypervisor was there. Now, for example, guest operating system 1, 2 and 3 is there. So now everything was on the top of the hypervisor. So bin, libs, everything is there. Now this is virtual machine architecture. What is the Docker architecture? Here in the host OS, in the top of that, instead of hypervisor, we will keep Docker engine. Okay, and in that only application will be there and containers will be there. So how we will try to understand containers are different from virtual machine. So in the Docker solution, standardize the runtime environment by bundling everything like application plus dependencies into a container. Did you get? Here, previously in virtual machine, what will happen? We will keep everything on the top of the virtual hypervisor. But here we will have three slab. Okay, OS will be there, bins will be there, and application will be there. For all we need a separate cabinet kind of thing. Now what Docker will do, it will you know containerization means it add all thing and give it in a bundle form, like application bins, libraries, operating system, all in one. And please try to say, maximum people say Docker does not have any operating system, but we should not have to tell like that. We should have to say Docker have a very minimal operating system. Okay, now portability. What do you mean understand by this? It means runs anywhere in a local machine, cloud or on-prem server, but it doesn't matter. It will do the same thing what you will do on your local machine and or cloud or on-prem. It will not have a impact. Now consistency. So same behavior in development, testing and production will be there. And it is lightweight, no full OS per application. But it doesn't mean operating is not there. Full operating is not there, because maximum dependency we will keep in the Docker engine, and whatever it is required minimal we will keep with the application. So it will have a very minimal operating system. Container will share the host kernel as their operating system, and it is scalable. It means it will be ideal for microservices and orchestration like Kubernetes and Docker Swarm as well. Now efficiency. So it will starts in second, and user uses fewer system resources. Now to understand Docker core concept, it is essential, but practical experience is what truly sets you apart. That's why in tomorrow class I will teach you a practical with one project. Now platform like Hostginzer or make it easy to deploy Docker container, allowing you to focus on developing and testing your application. So what do you mean by Hostginzer? So it will scalable infrastructure, provide an ideal environment for the learning and experimenting with Docker in a real world setting. So there is a seamless integration with Docker container. Ensure that whether you are running simple apps or complex multi-container setup, you can deploy with ease. So this is about what Docker solution give us. Now we understand what is Docker before Docker and after Docker we should, and Docker solution we also learn together. Now we will try to understand together what is Docker architecture and how it works. So for anything, when I was explaining Jenkins at that time also I have explained architecture even and Ansible, but today we are going to learn about architecture of Docker, and this is one of the interview question also, because in most of the interview they will ask this question. So without any further delay, let's understand the architecture. So Docker make us client server architecture. So the Docker client talk with the Docker daemon, okay? After that, which help in building, running and distributing the Docker container. So the here client will be there, okay? So it will directly not talk with whom it will talk. It will talk with the Docker daemon. And what Docker daemon will help? It will help to building, running and distributing the Docker container. So Docker client will run on the daemon on the same system, or we can connect the Docker client with the Docker daemon remotely. So this is the client, okay? It will interact with the Docker daemon. So now we will say as a Docker daemon, or this we can say as a Docker what we can say engine. So here what will happen, with the help of REST API or over a Unix socket or a network, the client and daemon interact with each other. How they will interact? With REST API? You just understand. To if see, the notes which I am sharing here is not my handwritten note. This I took from Geeks for Geeks. Why? So that every time, if I am not going to teach you only the limited things. If you want to know more about that, you can refer that Geeks for Geeks. That is a very good for us. That is free of cost, and you can refer that also. But here I am trying to explain. Okay. So see, client will be there. So user will talk to the client. Client, I want this. Now client will interact with Docker daemon with the help of REST API, or we can say Docker host or Docker engine. So this is that. So inside that, all information like container, how many containers is there, even image like Ubuntu, Red Hat, OpenStack, whatever the images will be there, volume, all information will be there to the Docker host. Now again with the help of REST API, it will go to the Docker registry. Registry will be also like OpenStack, Nginx and Ubuntu. Now what is the task of Docker host? Here we will use to create the container and everything. It will be there, and then we will only push it. So first stage is build, then pull and run. So in this is the what we can say architecture. We can say client, daemon, host, registry. So what is client? Client is nothing but Docker build, pull and run. Okay, now like client is nothing but which will interact with the user. Now client host means where we are going to host it, like operating system, Ubuntu, OpenStack, anything. Now, daemon means everything, like it is, we can say, the database of our system. It will have container information, image information, network information, every information. And registry is nothing but where we are going to deploy our application. So this is the architecture of Docker, we understand in a simple way. If you want to learn more, you can refer to the Geeks for Geeks. If you want, I will paste the URL also, so don't worry. Now, there is something that two things is there, Docker CLI and REST API daemon. So we'll try to understand what is Docker CLI. CLI means command line interface, that is used to interact with Docker. Okay, we can say some command like Docker PS, like that. The some commands will be there. That is nothing but Docker CLI. Command like Docker run, yeah, Docker build, Docker pull. So this is only CLI. Now Docker REST API. REST API means HTTP API used by the CLI and other tools. And there is some facilities communicating with the Docker daemon as well. Docker daemon will handle image, container, network, volume. So core services that manage Docker objects. So high level runtime manage containers, lifecycle operations, tasks include create, start, stop, delete containers. So there are some components also for Docker. So we will try to understand what is the Docker components. One second. Yeah. So Docker engine. Yes. So Docker engine is the key component of Docker, and it is a core part of Docker daemon that handle the creation and management of container. Dockerfile. So Dockerfile is a file, or we can say a simple text file that will describe the steps to create a image quickly. Now when we will understand Dockerfile, we will understand like single stage Dockerfile, multi-stage Dockerfile later. Now Docker image. What is Docker image? So Docker image is a read-only template that is used to create container containing the application code and dependencies, or we can say the image is used to create container containing application code and dependencies. Docker Hub. Docker Hub is nothing but it is a cloud-based repository which is used for finding and sharing the container image. So once with the help of Docker file, we will create a image. Now we need to push this image somewhere. Okay, we need some registry. So that is only Docker Hub. That is also a registry. So Docker registry is a storage distribution system for Docker image where you can store the image in both public and private modes. So this is, we understand, component. Okay, let's move to the another thing. Now Docker engine. So that only I told you, that daemon engine or host. So Docker engine is the core component that enable Docker to build, run and manage containers, and it will follow a very good thing, client server architecture, which means where the Docker client communicate with the Docker daemon to perform their container operations. So the Docker daemon, or we can say Docker Red, runs in the background, and it is the Docker daemon is responsible for managing Docker object, like that is, or that's why we used to call as a database also, like image, container, network, volume. So the Docker client, when client is there, okay, so it will send command like Docker build, Docker run to the daemon using the REST API, which act as a communication interface. Now the Docker daemon, which is the server component of the Docker engine, is the core component that provide the execution environment which images are instantly into the container. Now the Docker client. So the Docker client communicate with daemon using REST API. So Docker client, command line interface, daemon, API and other features, and container like container lifecycle, start, stop, pause and deletes. So this will is nothing but the client Docker is an internal architecture that will enable and like that. Now without the Docker engine, Docker image cannot be built or container execution. So the client sends Docker command, okay, to like Docker build or Docker run. Now daemon receive this commands and perform container operation, and the REST API is the interface enabling this communication. So in short, Docker Engine is the runtime that makes containerization possible by connecting the Docker client with the daemon to build and manage container efficiently. Now, Dockerfile. So, the Dockerfile uses a DSL, means domain specific language, and contain instructions for generating a Docker image. So, Dockerfile will define the process to quickly produce an image while creating your application. So, you should create a Docker file in order, since the Docker daemon runs all of the instruction from top to down bottom. So Dockerfile is the source code of the image. So Docker daemon, often referred to simply as a Docker, is a background service that manages Docker container on a system. So it is a text document that contains necessary commands which an execution helps assembly a Docker image, and Docker image is created by Dockerfile. Now, try to understand what is Docker image. So, Docker image is a file made up of multiple layers that contains the instructions to build and run Docker container. So, it will act as an executable package that includes everything needed to run an application codes, runtime, libraries, environment variable, and configuration. How it works: so the image defines how a container should be created, specifies which software component will run, and how they are configured. So once an image is run, it becomes Docker container. It's like image is created, okay, after that with the help of Docker build command. Now with the help of Docker run command, container will create. So Docker image is a blueprint of the Docker container, and Docker container is the running instance of Docker image. Now, Docker container. So Docker container, it is very lightweight, runnable instance of a Docker image, or we can say it is the package application code together with all its dependencies and run it in an isolated environment. So container allow application to run quickly and consistently across different environments, whether on a developer laptop, test server, or production. So a container is created when a Docker image is executed. It runs as an isolated process on the host machine but shares the host operating system kernel. So multiple kernel can run on the same system with interfering with each other. For example, suppose there is an image of Ubuntu operating system with Nginx server. So when this image is run with a Docker run command, then a container will created and Nginx server will be running on Ubuntu server. So relation of image. Docker image is a blueprint, a static read only, and Docker container live instance of that blueprint. Now, see, don't worry, we will understand this, and later I will I will explain something, and we will learn together. Now, what is Docker Hub? So Docker Hub is a repository service, and it is the cloud-based service where people push their Docker container image, or we can say Docker image, and also pull the Docker container image from the Docker Hub anytime or anywhere via the internet. Now, generally it makes it easy to find and reuse image. It provides features such as you can push your image as a private or public repository registry where you can store and share Docker image. Many DevOps team uses the Docker Hub. It is an open source tool and freely available for operating system. It is likely a storage where you store the image and pull image when it is required. So when a person want to pull image from the Docker Hub, they must have a basic knowledge of Docker. Let us discuss the requirement of the Docker tool. So though the introduction essential Docker command became a powerful software streaming the container management. So first is Docker run. Not first, but I am trying to explain. First is Docker run command. So it will use for launching the container from image with specifying the runtime option and command. It fetches the container image from the container registry like Docker Hub to the local machine, and it helps in displaying the running container along with their important information like container ID, image, uses and status. Docker stop, it is used to halting and running container gracefully shutting down process within them, and Docker start will help to start or stop the container, and login will help to log into the Docker registry. It is a two edition, community edition and expert enterprise edition. Now let me tell you that tomorrow tomorrow I'm thinking like this session will be too long, so tomorrow only you will get another session, and after that you will get another session. So total 3 days will be there. This is day 1. In day 2 also I will explain something, and as well as I will try to show some practical, and in the day 3rd, that will be total one project I will explain, and I will do in front of you, and we will do together. So thank you for watching Study with Varsha. Have a great day.